You are warmly welcome back to our series on differentiation. This is GORDMATHS, where mathematical literacy begins. In today's lesson, we will discuss the reciprocal rule and the product rule. Remember to subscribe to this channel for more interesting lessons. We apply the product rule of differentiation to functions that are products of other functions. Consider the function f of x is equal to x squared x plus 1. This function is a product of the function x squared and the function x plus 1. And so we can represent the function x squared by g of x, and then the function x plus 1 by h of x. So we would say that the function f of x is equal to g of x times h of x. Now, if we have a function of this form, then the derivative of this function, which we will represent by f prime of x, is equal to g prime of x times h of x plus g of x times h prime of x. This is the product rule of differentiation. So if we have two different functions multiplying, then we differentiate the first function and multiply by the second function, plus the first function multiplied by the derivative of the second function. We will consider a few examples on this. Let's check the following examples. In the first question, we have the function y is equal to x cubed x plus 4. Since this function is a product of two other functions, then we can apply the product rule in finding the derivative of this function. Let's say the first function is f of x, and that is equal to x raised to the power 3. And the second function is g of x, which is equal to x plus 4. Then the derivative of this function f of x, which is f prime of x, will be, using the general rule of differentiation, 3x squared. That is 3 multiplies the function and we subtract 1 to get this. Then with g of x, the derivative, which is g prime of x, is equal to, when we differentiate the variable x, we will have 1. Then the derivative of a constant is 0. So the derivative of g of x is 1. Then applying the product rule, which says that dy dx is equal to f prime of x times g of x plus f of x times g prime of x. We would have f prime of x is 3x squared. So 3x squared times g of x is x plus 4, plus f of x is x cubed, and then times g of x is 1. So expanding this, we will have 3x cubed plus, when we multiply this, we have 12x squared plus x cubed. And that will give us 3x cubed plus x cubed will give us 4x cubed plus 12x squared. Then to the second example, we have the function f of x is equal to x squared plus 1 multiplying x minus 3. So since f of x is a product of two functions, x squared plus 1 and then x minus 3, we can apply the product rule. So let's suppose the first function is g of x, and that is equal to x squared plus 1. When we find g prime of the first function, we will have, this gives us 2x, and the derivative of a constant is 0. Then the other function we can represent by h of x, which is x minus 3. The derivative of this function, h prime of x, is equal to 1. This gives 1 and the constant is 0. So using the product rule, the derivative of the function f of x is equal to, since it's the product of g of x and h of x, we will have j prime of x times h of x plus j of x times h prime of x. So we put these ones. G prime of x is 2x, then h of x is x minus 3, plus g of x is x squared plus 1, and then h prime of x is 1. So simplifying this, we have 2x squared minus 6x plus x squared plus 1. So we will finally have 2x squared plus x squared gives 3x squared minus 6x plus 1. We would also look at the reciprocal rule in differentiation. Before we consider the reciprocal rule of differentiation, let's look at how to differentiate a function that is raised to a certain power, or a function that has an exponent. This is very useful in applying the reciprocal rule. Consider the function f of x is equal to x plus 3 exponent 2, and a function g of x is equal to x squared minus 1 exponent 3. How do we differentiate such functions? Now, in finding the derivative of these functions, we first differentiate the entire function, which means we multiply the power by the whole function and subtract 1 from the power. And then we differentiate each of the terms inside the bracket. And so the derivative for this function, f prime of x, will be, in differentiating the entire function, we multiply the function by 2 and then subtract 1 from this. Then this is multiplied by the derivative of the function inside the bracket. So differentiating x, we will have 1, and then the derivative of a constant is 0. So we will have 2x plus 3 all raised to the power 1, which will not be written. And we can expand this to get 2x plus 6. That is the derivative of this function. Now looking at the second example, we have g prime of x, which is the derivative of the function g of x to be, we multiply the entire function by this power, and that gives us 3x squared minus 1. Then we subtract 1 from this power to get 2. This result is multiplied by the derivative of the terms inside the bracket. So the derivative of x squared is 2x minus the derivative of a constant is 0. So since these two are multiplying, we can multiply 3 by 2x, and that gives us 6x. Then we multiply that by the function in the bracket. So the derivative of the function g of x here is 6x in bracket x squared minus 1 all raised to the power 2. This is very useful in applying the reciprocal rule of differentiation. Let's look at how to use the reciprocal. In our lesson on indices, we learned that when we have the expression 1 over x raised to the power 2, it is the same as x raised to the power negative 2. This is called the reciprocal of this function. So consider the function 2 over x raised to the power 5. Then the reciprocal of this function is 2 times x raised to the power negative 5. So x raised to the power 5 here multiplies the numerator, and then the exponent changes to the negative. Assuming we have the function f of x is equal to 1 over x squared plus 1. Then, since this whole denominator is raised to the power 1, we can write this function as x squared plus 1 all raised to the power negative 1. That is when the denominator is moved upwards to multiply 1, and then the sign changes to the negative. Now, if we want to differentiate this function, then we use the power rule as we have previously done. First, we will differentiate the entire function, which is we multiply the function by negative 1 and then subtract 1 from this. Then we multiply what we get from the derivative of the function inside the bracket. And so we will have f prime of x to be equal to, since we are using the reciprocal function, we will have negative 1, the power here, multiplying x squared plus 1, and then we subtract 1 from this negative 1, times, inside the bracket, we find the derivative of each term. The derivative of x squared is 2x, and the derivative of 1 is 0. This will result in, since we are multiplying, we can multiply negative 1 by 2x here, and that will give us negative 2x. Then in bracket, we have x squared plus 1 raised to the power negative 2. This can be written as negative 2x over x squared plus 1 all raised to the power 2. And this is also an application of the same reciprocal rule. When we have this, we can write it in this form, and when we have this, we can also write it in that form. Let's take another function. Say g of x is equal to 2 over x plus 1. Then this can be written in the reciprocal form as 2x plus 1 raised to the power negative 1. That is, all this is raised to the power 1. Then we use the power rule to differentiate this, and so j prime of x will be equal to negative 1 multiplies the entire function. So negative 1 times this will give us negative 2. Then in bracket we have x plus 1, then negative 1 minus 1. This is multiplied by the derivative of the function in the bracket, x plus 1. The derivative of x is 1, and the derivative of 1 is 0. So since this is multiplied by 1, we will have this function, negative 2 x plus 1 all to the power negative 2. And this will be written as negative 2 divided by x plus 1 to the power 2. So note that when the denominator is moved upwards, the power changes its symbol. And when it's moved back as a denominator, the symbol again changes. We will take a few further examples on this. Let's find the derivative of each of the functions below. For the first function, we have f of x to be equal to 3 over x plus 2 squared. And this will be written in the reciprocal form as 3x plus 2 to the power negative 2. Then in differentiating this using the power rule, we will have f prime of x to be equal to the power negative 2 multiplies the entire function. Negative 2 times this will give negative 6. Then in bracket we have x plus 2. Then negative 2 minus 1, that will give us negative 3. This is multiplied by the derivative of the function in the bracket is 1. And so we would have negative 6x plus 2 raised to the power negative 3. And this is negative 6 over x plus 2 raised to the power 3. Then second question by yourself, and that's your assignment for this lesson. In our next lesson, we will look at how to differentiate implicit functions, which we call implicit differentiation. See you in our next lesson.